Thanks for the chance to give the talk. If you are on the web, you don't see there's probably a lot more of you, I hope, online than there are in the room. But the topic that I was asked to talk about was to talk about open access to data, and so I'm going to actually put this inside the context of the recent executive order on making open and machine readable the new default for government information. And my goal is not to take a lot of sides, but to try to point out different ways that we might think about why this order exists, the kinds of things that regulate data from a utility perspective, and different ways we can think about how to value the impact of making data open and machine readable and how it might increase the value of that data. Because I think that data is new enough that we don't have a very common way of talking about it, especially the sort of size and the scale of the data that we have now is culturally fairly new to most people compared to documents which we had on the web. So I wanted to start with why this might be an interesting question. And so everyone talks about big data. I like to talk about cheap data because cheap data to me is more interesting than the size or the scale or the analytics. When data is scarce and expensive, people behave in one way. When data is cheap and bountiful and easily regeneratable in some cases, it changes the way that we think about whether or not we know something, right? The justification that we have for belief, and that's what epistemology means. So I actually was a philosophy major, and I love to throw epistemology in early because it's one of the places where I actually have more training than the people that I talk to. And epistemology really is, right, what makes a justified belief justified? And I try to stick to easy things to use to illustrate the example. So how do we create justification for the belief that someone was a good hitter in baseball? It used to be an instinctive thing that scouts did. And now if you want to justify whether or not you believe someone is a good hitter in baseball, right, we use mathematical formula and statistics and models, right, to predict whether or not someone's going to be a good hitter next year based on what they've done in the past. And this is the formula for one of those factors that's used in baseball. And so it's the epistemology of predicting whether someone's going to be a good hitter in the future has changed because the data is so cheap and so computable. This has happened in just about every field you can imagine, but it's particularly powerful in fields that are narrative-driven. Politics underwent this change over the last 2 presidential elections. Weather modeling has undergone this change over the last 25 years or so. And I think biology and health, which are deeply narrative-driven, are the next ones that are going to get hit by this. And so opening the data is in many ways an attempt to reflect that justification change. Because if you can't examine the data behind the formula for batting, if you don't understand where that formula came from or how it works, you cannot trust that the decision it arrives at is justified. So that's why I think this makes sense. It's a way to reflect what's happening because of cheap data. Right? And that mirrors what we saw in software. So software became cheaper to create, easier to create, and it was democratized. The capacity to actually build it was radically democratized when we got personal computers, and as those computers got connected to the network. So software went from being something you went to university to study, computer science, to something where now I think that one of the 2 AP exams in computer science has been dropped, and we are now generating less than 10,000 computer science graduates a year in American undergraduate school. Right? And that's a reflection of what happens when software tools got democratized and software became cheap. Now, open source becomes possible in this because you can take some subset of that cheap democratized software creation and make open source stuff out of it through collaborative systems and standard legal tools and so forth. And if you are only caring about economic impact, the 2008 report says 60 billion per year savings as a result of open source software. So maybe the open mandate is about reflecting the epistemology. Maybe it's a purely economic attempt to save people money. Maybe it's an attempt to get innovation. And depending on who you talk to, they're going to give you a different piece of that elephant. Okay, so that's the start. Now, I'm going to go back to the big data word, right, and say, what's it like as we experience it? If we're going to make data open and machine readable by default, it's good to start with how we experience it today in a way that's not necessarily open or machine readable. The vast majority of us experience big data as advertising, right, as targeted advertising. So this is a rather old screen cap of my Amazon And you can see the Kindle recommendations that are being made for me, right? And they're fairly good, right? Predictably Irrational is a book that I bought relatively quickly after it was recommended to me by the data algorithms that Amazon recommends things with. I have an interest in math. I have an interest in the way people make choices. So that's a pretty good, right? There's some parenthood books in here. I have a 2-year-old. So Amazon knows that because of the fact that we belong to Amazon Mom, as well as the things that we look at. So there's all sorts of things that make sense here. Also the fact that I like science fiction, that I've been reading some criticism of technology. All these recommendations make total sense, but that's the main way that we experience the technology. And the impact has not been to make us data literate and to want access to the raw data. It's that we want those titles on every device, right? So if you've not seen Willy Wonka in a while, Veruca Salt is the character who says, "I want it now." And that's been the main impact of data from a consumer perspective, is I want all of my books on my phone, on my tablet, on my PC, on my television. I want them wherever I am. I want them at that moment. And I want those recommendations now and at that moment. So this doesn't really argue for making things open and machine readable as long as we get the things that we want as consumers. That's sort of where I really feel like we experience it. And this is where the economic argument is right, this is Google ad revenue compared to U.S. print media revenue, with Google being the one in red. Right? Kind of catching up. What's really stunning is the drop in U.S. print revenue. The other thing to point out is, of course, that this is Google's worldwide ad revenue versus U.S. revenue. It's a good example of how not having the data be open make it relatively easy to fudge your chart. The U.S. part had to go back and be added in by people who analyzed this post hoc. But you can dig into it. You can see ad expenditures by medium and market shares of internet portals. This is where the money is. This is where the economic benefit to the U.S. country and economy from a jobs perspective of big data has been hitting, is in advertising, powered by mobile, powered by social. And we could look at it in the context of banking, but that doesn't create that many jobs per capita. It creates more wealth per job, but a much lower number of net jobs. And when people talk about open data for good, they almost always refer back to, again, these same closed systems. So this is Google's Superstorm Sandy maps. If you wanted to find a gas station that was open after Sandy, right, Google opened up its maps, by which that means they allowed people to use the API to do things. They didn't actually make the data open or machine readable. They allowed the API to be integrated with other existing data that people themselves added. And it created a very good outcome. It made Sandy more tolerable because you could find gas. And you could find the closest station next to you that had available gas that was open. And this is the sort of thing that when you sort of press on open data for good that you tend to hear about. It's not usually science-based. It's not usually research-based. It's very consumer-focused, and it looks a lot like the things that big data drives in advertising. It's based on these sort of small-scale, important human-scale tasks that the consumer web is really good at. But if we're going to do this for all government information, and implicitly the NSF's information and other research data that's funded, right, we need to have some way of understanding what the economic value is of doing that. Right? And to do that, first you have to figure out what's the economic value of the data itself. Now, Google won't tell us the economic value of their maps data, and they won't give it to us. Right? TomTom won't give us their economic value of their GPS traces, right? And they won't give us the data. So we have to find different ways to assess this because we don't actually know the real economic value of those things unless you're going out and buying them. So one way that's been proposed by economists is commitment to data. Commitment to preserve and keep and store and serve data is one of the ways we measure the value of any given data set or file. So Amazon's got a nice commitment to preserve and archive public data sets in the cloud. Right? That commitment is an indication of value that those data sets have compared to data sets that have not received that commitment. That's one way we could go. And data.gov is another example of that sort of commitment to at least index, if not maintain the actual raw file. To maintain an index of the locations of files is a commitment. And we can use it to assign some sort of economic value to that data. Right? In a more classic scientific sense, right, citation is another way to infer the economic value of the data. And so you've got journals that do nothing but publish data sets so that they might become first-order research objects and get citations. in much the same way that a paper has an economic value to the scientist who's up for tenure, a data set that got cited would have a similar economic value to that scientist when they're up for tenure. And you see this not just in an individual journal context like I just showed, but the national academies and others have been pushing larger and larger sort of cross-disciplinary programs like DataCite so that you can begin to assess post hoc that a data set was valuable because of the amount of usage it got, right, as an inference through citation. And then, of course, price is the classic way to infer the economic value of any good, including data. Data marketplace, this is, some of it's public data that's been curated and reconfigured to become more usable. Some of it is private data that's just been placed as an asset, but you can go into a marketplace and you can buy it. And even Microsoft actually has a data market that's very much like this as well. And you've got things that are free but have been subject to some value-added work by the company, and then they're priced. You can go buy them. And your choice is either to do the curation yourself on the free data or to skip that and buy it. As long as it's priced right, you'll do that. So that's three different ways, right? Commitment, citation, and price that we might guess at the economic value of data. I believe in a fairly different way to think about the value of data economically, because there is some data that we know is going to be valuable to a lot of people, right? The census is a kind of data that we know is going to be valuable in a broad, unfiltered way. But the vast majority of data are going to be valuable when someone finds them who needs them and connects them to other sources of data to produce questions or answers that would otherwise not be possible. And so it's sort of the ultimate one man's trash is another man's treasure argument, because we don't know how valuable a data set is until someone uses it to do something that we didn't expect that creates value. So this is one of the first people I worked for back in the late 90s, Jonathan Zittrain. He's a professor at Harvard. He's also pretty involved in wireless and spectrum and other things in broadband here. I think he's actually doing a chat right now on cybersecurity. And he's articulated this idea of generativity. It's not his original concept, but he's articulated, I think, better than anyone. And it's this capacity for unanticipated outcomes, right, from unfiltered contributions from varied audiences. So people you don't know doing things you don't expect to contributions that you don't have a filtering system for. And that this is the capacity that made the internet capable of spawning email, FTP, and the web of spawning everything that the web has spawned. And in many cases, what you do not have in the walled gardens of Facebook and Twitter and some of these other systems, where by default you have to apply for permission to make a contribution. Where you as a user are filtered, where you as a user are less varied or less broad, where there is control applied, right, at the change level, the contribution level, and the audience level. And so this is how I would propose that we think about the value of government-funded data, is that by definition, the most interesting uses have probably not been found yet, and they may not be found by people who we give the money to. So the goal of making things open and machine readable is to make them generative over the long term, so that someone finds a use for it 10 years from now and they don't need permission to get the data, to make the change, or to be part of the audience. And this is really just an observational element of how the networks have emerged. We could have gone multiple ways with the internet. This is from one of the earliest ARPANET papers. It's a fairly famous piece of web geography. We could have had a centralized system, right, with DoD in the middle. We could have had a distributed system where we force the network to be fair, so that every node has only an equal number of links to every other node in the network. But what we got in the end was one that could evolve, it could compete, where the hubs wind up controlling 80% of the links compared to the other small nodes. And what's nice about the central diagram is it's fundamentally generative. It allows for new hubs to emerge, old hubs to fade, right? Yahoo and MySpace are hubs that might have been pretty dominant 7 or 8 years ago, but are pretty faded now. And so that's what I like about this capacity for unanticipated change and emergence from unexpected places, is it really fits into how networks have scaled in the past. And if that's going to happen in data, my gut is that it's going to happen the same way that it's happened in documents and it's happened in computers, through this sort of evolution of scale-free networks of reuse. And in a lot of my previous work, I've focused on trying to get the critical mass to the point where we're not talking about Moore's law and just processing, we're talking about Metcalfe's law and the value of things starting to grow as a function, right, of the amount of those things that are out there if they're compatibly communicated. So if you have one fax machine, it's not very useful. If you have 100 fax machines and 100 fax protocols, it's not very useful. If you have 100 fax machines using the same protocol, you start to begin to get towards that flipping point of Metcalfe's law. And I don't know if it's the square of their number or the log of their number or some other factor, but and there's a lot of, exactly. Right. But this is sort of the argument that I like to come back to is with data being open and machine readable, we should in theory be able to make data sets compatibly communicate with each other. And if we can get enough data sets compatibly communicating, at some point we're going to start to see a network effect. We haven't really seen it yet in the open world. We've seen it inside firms. We've seen it inside Google, inside Facebook, inside Goldman Sachs. But we have not seen it outside the firm yet because in many ways the transaction costs of making data hit this flipping point, right, are lower inside a firm because you can force everyone to use your systems. You don't have to have negotiated standards. You don't have to have consensus. You can fire people who don't do it your way. And that's the classic argument in open source is there hits a moment where the complexity of doing something outside the firm drops and the transaction costs outside the firm drop. That complex things are easier to do in a distributed context than inside the firm. We haven't hit that yet in data. But that's where I think this machine and open default is going. So if we're going to think about it this way, right, about generativity, we get into how are you going to actually score it? Because if we're going to increase something, first we have to be able to measure it, at least in some sort of hand-wavy fashion. And so the four axes that Zittrain lays out are accessibility, adaptability, leverage, and ease of mastery. And these are not particularly easy things to make quantitative, so I'm not going to show any numbers here. I'm going to show some hand-waving qualitative stuff. And generally speaking, accessibility has technical and legal parameters. Right? Do you have to register before you can download a data set? Do you have to log in? Is it subject to excessive copyright or other kinds of restrictions that prevent you from getting a copy and making a copy? Is it adaptable? Do those legal agreements prevent you from editing or integrating or otherwise reusing the file in a creative way? Is it in a format like PDF that prevents that sort of transformation? Right? That's adaptability. Right? Leverage has to do in many ways with how you can do things that weren't expected. So the PC was a highly leverageable instrument because you could use it to write software that its designers never imagined you would use it for. And so leverage in data is a slightly different and harder thing to quantify when you think about this, but that's the idea, is how easy is it to use it for something that no one ever expected? And then ease of mastery. And so how quickly can you pick it up to do something that leverages it, right? And so these are the four parameters that Zittrain has laid out that I tend to go with. If we're going to score generativity, it's going to be along these 4 points. But before you get into scoring that, you have to think about what regulates. And in data space, data tends to be regulated by at least 4 things. There's probably more. I've oversimplified them, but this gives us a nice picture and a way to think about it. So intellectual property does govern data. In the United States, at least, especially with government data, there is no copyright, which means that the ability to prevent copying and distribution of data once it's on the web is quite low. But one form of intellectual property people don't talk about is trade secrecy. Trade secrets are a form of intellectual property rights, and they're the primary regulating force from an IP perspective on data. So if you want to buy TomTom's GPS data, they salt it with fake roads that are unique to your copy. You sign a punitive contract agreeing that you've received a trade secret from them. And if you violate that, they'll know it's you because those fake roads they've salted it with create a watermark for your copy. And you become immediately liable for having breached trade secrecy. So that's the primary place where IP regulates in U.S. law. In international law, in the UK and Australia, there's some light IP that applies to the effort of going to the collection of a database. And the European Union has database protection laws that creates a copyright-esque right, but only over a collection of data, not over a data file itself. So for the most part, it's trade secrecy that regulates from an IP perspective. The other place where you get a lot of legal regulation in data is contracts. So you get crustier and crustier and crustier contracts the more valuable people think their data is, right? Where it's the exact opposite of generativity, the way these things get drafted. They try to only let you do the one thing that you thought you wanted to do when you got the data, which is also the opposite of science, which is getting in, flailing around a little bit, realizing you were completely wrong with your hypothesis, and then coming up with a new one. And the vast majority of the way that the IP is enforced in contract space actively prevents that. In many cases, reinforced through digital rights management or other sorts of technical surveillance that will shut down entire college campuses if you start doing data research in ways that weren't part of your contract. Right? I know of a health data company that blocked an entire Ivy League university for a month because one postdoc was doing exploratory computational research in the data that was not an explicit part of the contract. It wasn't explicitly forbidden, but it wasn't allowed. Right? So that's one of the ways that we regulate data that is perhaps makes sense in a consumer world. It makes no sense if we're trying to stimulate innovation on public data. But unfortunately, nobody goes to law school to learn how to give things away, so we have to sort of start with that. Another thing, obviously, that regulates data is the technology. I don't have to go into too much here, but if you don't have good ontology or taxonomy, if you don't have good names for things, if you don't know where the data came from or some way to trust it, if you don't know what version of the data you're looking for, if you don't have the ability to seamlessly transfer that data from place to place or at least authorize from place to place, and if you're not dealing with formats, right, data is heavily regulated. One of the funniest things that I found over the last 5 years is how many people told me they were giving me their data and sent me a PDF. Right? A PDF is like someone taking a photograph of data and mailing me the JPEG. Right? Especially if they put it into columns. Because if you try to do a cut and paste out of PDF across columns, it'll actually just cut you the horizontal stuff. Right? It's worse. Right? I tend to wind up rekeying it by hand because it's faster. And this is the sort of thing that when you say, I'd like to see technology that makes data access easy, this is a map of some of our technology architecture at SAGE, which is where I spent half of my time as the chief policy officer. All we want to do is let people who don't know each other collaborate on data to build predictive causal models. And in order to do that, this is all of the stuff we have to build and then hide. Because if the users actually saw this, they would never bother with it. So in order to make it possible for a life scientist in Boston to collaborate on a computational experiment with a life scientist in Seattle, you have to first build this and then make it invisible, because it regulates the data that much. Policy, obviously, the making of the data open by default is a major regulator on the value of that data, but also safe harbors. Right? Things like under HIPAA and other kinds of privacy law, the idea that you've de-identified it to a certain level that you don't have to apply to an authority to then go share it. Right? Those sorts of safe harbors allow for lots of experimentation that otherwise would have a very high permission cost. I like the idea. Did I hear something? Okay. And I quite like the idea of estuary models, right? Estuaries are, combined salt and freshwater spaces. They're very diverse ecosystems. So places where we can have both public data and private data that's mixed in sandboxes, I think, are going to be really important policy incentives for things to happen. And this idea of we're going to pay for it once and use it many times as a policy rule. These are policy things that really change our ability to regulate data and reuse it. If you ask scientists that are funded by the government, for the most part, for copies of their data, if you don't have these sorts of policy positions in place, right, the old joke is that data mining means the data are mined. And that's what happens in the absence of this sort of policy regulation. And then privacy, which I mentioned briefly, is probably the least thing that many scientists think about when they think about data. But it's going to be bigger and bigger. And I actually wrote these slides before the late unpleasantness, as we might refer to it, over Mr. Snowden. Right? But there's this tension between the utility of the data and its anonymity. And there's an enormous capacity that's been created by the big data consumer web to probabilistically identify somebody without having to come up with their name. Right? It's the loophole that allowed diapers to show up at my house 3 days after we got home from the hospital with our new baby, addressed to occupant. That allows, right, Pampers and Amazon to claim that they didn't sell my name. Right? They sold a demographic slice attached to an address and a probability of a new baby at that address. And the penalty for being wrong there is that they sent 10 diapers, and they wasted a box, and they wasted some shipping. Right? But there's this tension between the data being useful and actually being anonymous in the way that people expect it to be. And in the sciences, that's particularly dangerous, because if we salt the data to make it anonymous, right, if we put fake data in to make it jittery, that reduces its scientific utility. So that's not an option that we have available to us. The ease of re-identification is something that most people don't understand, right, as a regulating factor on data. If people understood exactly how re-identifiable they were, people might not sign up for as many loyalty cards at stores as they do. But there's arguments over this, but my favorite number is 87% of the U.S. population is identifiable solely by their birth date, zip code, and gender. Now, that result has not been replicated, but they do. The woman who did it up at Harvard, LaTanya Sweeney, does have a calculator up on the web where you enter in your zip code, and you find out how many people have the same birthday and gender as you in your zip code. I'm the only person with my birthday and gender in the last 4 zip codes I've lived in. So take it for what it's worth, and I'll circulate the link so you can try it out yourself. Right? It is remarkably easy with a set of data points about an individual to vector in on the odds that that's a specific person. And then a lot of people like to talk about changing norms of privacy, that the millennials simply don't think that they have privacy or want privacy. I actually don't necessarily buy that. But clearly the way that we talk about privacy is changing as people start to overshare and perhaps massively overshare. Okay. So if those things regulate, what do we do to increase the generativity of the data set? Which of the levers inside policy, privacy, tech, and IP do we pull? Now, copyright is one approach that we can take. In some cases, copyright may or may not apply to data. In many cases, people assume it does, which makes it a useful tool even if it legally has no power. So we could use Creative Commons licenses on data. They're called out specifically in the executive order and in the Holdren memo, right, putting open licenses on data. It's not clear we can use these in the government. Right? The government data doesn't have a copyright in the United States, does have a copyright outside the United States. So I had a surreal argument once with a government attorney before I came on board here. This was several years ago, where they said, we can't use a Creative Commons license because we don't have a copyright in the United States. So I said, well, you can use it to apply outside the United States. They said, well, yeah, but then people in the United States would get a copy of the data with a license on it. And having this sort of brain freeze, like, but then the license doesn't work. At any rate, open sourcing licenses on the data is a way to give a semiotic indication that it's available for reuse. From an IP perspective, it's the opposite of trade secret to put a CC license on it. Right? You can put it in the public domain, right, through a dedication. You can deal with privacy through things like one of my own projects, which is trying to get people able to donate their data to research by coming up with consent processes that say, at least for me, I don't really value my privacy compared to the research value that my data can create, so I'm going to actually donate my data to research and accept, right, the tension between anonymity and re-identification. I'm going to accept that my data may be used in ways that make me uncomfortable. So we can deal with the privacy and the technology and the IP stuff through this. Right? We have policies, like the NSF data dissemination policy and the memo that we've got. Right? And each of these are attempts to pull the levers. But the problem is we don't really have any non-fuzzy understanding of why this is useful. And we haven't come up with any sort of actual cases that we would analyze. So what I wanted to do is to do a little hand-waving and score this in 2 kinds of open government data. One is out of the Energy Department, one's out of the NIH. So going back to those 4 axes, and so a couple of points that came out. So I've probably looked at 100 data sets in the past with this lens on them. The first is that adaptability and accessibility are pretty strongly correlated with each other, which is not surprising. If you're going to put something up on the web and not make it a heavily controlled document, then it's probably going to be both accessible and adaptable because you're not going to have lots of excessive controls on it. It's not necessarily a causal relationship, but it's pretty strongly correlated, and it's often causal. And data.gov is a great example of this. The other point is that accessibility is a necessary piece of adaptability, but it's by itself not sufficient for adaptability. And this is perhaps the easiest switch to pull if you want to create more value, which is why I think that policy makes so much sense. Is the policy basically is an accessibility policy. That's the open part. And the adaptability part is the machine readable. So you see that correlation even in the policy. Adaptability, in turn, correlates pretty strongly with leverage. Right? Accessibility and leverage are only correlated through adaptability for the most part. Sort of by definition, it's easy to do something that people didn't expect if the data are easy to adapt and make changes to. The things that make adaptability better are things like curation, standard use of identifiers and metadata, right? Application of good ontologies, right? Those make things more adaptable. They also make them easier to leverage. Again, not necessarily causal, and adaptability and accessibility are necessary, but in turn not sufficient for leverage. And where we are right now is that for the most part, if you want to leverage health data, you've got to know something about health in order to leverage that data effectively. Otherwise, you're going to make choices that just don't make sense. And adaptability is a much more expensive thing than accessibility. And if you look at that executive order, that's what I think we're going to find in the implementation stage, is that the human expertise and the domain expertise needed to make data adaptable and leverageable, right, which tends to mean semantic, annotated, curated, with good provenance. That's a lot more expensive, and it's an unfunded part of the order at this point. Right, so that's one of the reasons why when you look at open data, you find a significant bias towards accessibility, right, a less significant bias towards adaptability, and a really low bias towards leverageability. And ease of mastery is kind of funny. I'm not going to go into detail on it, but ease of mastery sort of has two versions. One is it easy for a geek to use? And one is it easy for a normal person to use? And the choices that get made in between those two have a radical impact, right? So if you make something easy for a normal person, you almost always make it unuseful for a programmer. And in many cases, the same applies the other way. And I'll show you an example of that. Right, so when you focus on the user, you typically assume a naive user, so you don't expose the raw data, you don't deal with licensing, you don't deal with annotation. And it often can actually offset, right? The focus on ease of leverage or ease of mastery for a non-expert user will often kill your adaptability, accessibility, and leverage. It's really interesting because PDF visualizations, right, pictures and graphs, tend to be the way that ease of mastery is applied for naive users versus programmers, right? Or insertion into sort of the flavor of the week's piece of software. So if we could come up with a way from a funding perspective to mix ease of mastery and accessibility, right? So you've got that beautiful version for the naive user that's in Google Earth, like I'll show you in a second, plus the download of the raw file with enough annotation, that might be a sweet spot. Those are sort of high-level observations. And then I'm only going to do two quick cases to show you. So this came out of the National Renewable Energy Lab in Colorado. This is the Western Wind Resources data set. It's a beautiful data set of wind turbines, their latitude and their longitude, their make and their model, their functionality, and their the power that they produce. And they put all this data into Google Earth, right? So it's gorgeous. You can zoom in. I lived in the Bay Area for a while. We would drive through wind farms, and we would drive out to the east from the Bay Area. And it's kind of neat. You can see all these turbines, and even on your phone, pull them up and see which ones are more effective than other ones. Right? And so this is a pretty good ease of mastery interface to the data set for a naive user. Now, you are able to choose the metadata file here on the left, choosing a station ID from the metadata file, and type it into the form below. Now, let's analyze the legal aspects of this. There is no bespoke license that applies to this data set. They haven't declared anything. In the absence of that, you have to assume that the website copyright governs all the things on the website, including the data set. Now, the copyright status of classic government copyright says, right, the NREL authored documents are sponsored by DOE. As such, they're able to be performed publicly and made available. but it says use of documents available may or may not, may be subject to U.S. and foreign copyright laws. So in the absence of an open indication, we have to assume that this data set is in fact a closed data set from a legal perspective, and we don't have the right to download it and redistribute it. Even though that is not, in fact, the intent of the people who put the website up. But this is what happens when you don't mark every data set with the legal status of the data set, is that whatever structure it's reified into, that document's legal structure applies. So if we're going to talk about this from a naive user perspective, it would be fairly high on ease of mastery, fairly high on accessibility. You can download that metadata file, and I'll show you what it looks like. It's not particularly adaptable because you could just add annotations to Google Earth. You could add pins and flags inside Google Earth. But since you can't easily find the raw file and understand it, you can't make a lot of mashups out of it. You can't make a lot of hacks with it. The use case that we came up with was, let's say we wanted to put wind turbines in on a mountain in East Tennessee where I grew up. We wanted to find all the turbines in California that operated in high humidity areas at high power throughput and high longevity. To do that, we would need to be able to cross-reference this data set with weather maps that told us the weather of those areas, and with sort of solar maps that we knew what sort of solar and wind maps we could get out of it, right? You need at least 4 sources to triangulate on that. And so that should be easy, but unfortunately it's not through at least this UI. When you click on the actual annotation, right, this is actually modeled data. So this is not necessarily even observed real data. Some of this data came out of a predictive model that's operated by the Weather Research and Forecasting Group at NREL, or NCAR. So it turns out that we need to be able to understand the model before we can even really understand whether or not we trust the data, to what extent we trust the data. And the model, of course, gives us this. Right? This is what you get when you download the metadata file, which turns out to actually be the data file, not the metadata file. And you say, okay, well, now that we know that we've got the data file, maybe it's a lot higher on the leverage scale and it's higher on the adaptability scale, right? They're using Latin long. That makes it pretty easy to cross-reference and pivot into other data sets. There is no punitive license applied to the actual Excel file that you download. It's a CSV file. There's no barrier to that. It's on the net. It's not subject to a click-through or any sort of other click wrap. So it's actually better than it looks on first guess. But when you do this, you see obviously that CSV file has a very low ease of mastery for a naive user, while it has a very high ease of mastery for a programmer, especially one who understands geospatial coordination. Now, the model that predicted this, if you try to click through and it takes like 30 minutes to try to find all the parameters that went into creating this data set. The model that predicted this is itself not open and transparent. So you click through to this, you find out it's a next generation model. It's been a collaborative cooperation. It's got multiple dynamical cores, a 3D dimensional variational data assimilation system, right? This is a nice heavy piece of hardware software. But if you actually tried to see it and find out how it works, that's a lot harder for a naive user to do. So that generativity, you got to give it a hit on generativity again, because if you can't understand the model that generated the data, it's very difficult to think about why you're going to use that data. And this is the best metadata I can find on the WRF model, is a slide from a PDF describing the model at a weather modeling conference. And so this is, when you actually put things to the acid test, this is what you find, right? So here's where we would score it in the end, is that it's actually not that easy to use unless you're using the Google Earth UI, which gives you a negative hit on the other aspects of it. It's accessible for the most part, no matter what you think, simply because the files are on the web without constraint. The leverage is low because we don't understand the model. Right? The adaptability is low because we don't understand the model. But if you're a programmer, you get the blue graph. If you're a regular human, you get the gray graph. And so that's a way that you can see government investment in data affects the generativity of the data set because of the way that it's used. Now, private investments on government open data are another way we can think about this. And so I'm saying private in the just non-government sense, not for-profit or non-profit. So this is the Cancer Genome Atlas. It's been in the news a fair amount lately. It's an attempt to comprehensively map key kinds of cancer, right, to map the genomes of those cancers in a relatively exhaustive way. It's nice, right? You can get access to really high-grade, large-scale data here. And if you click on download data, you get 3 ways to download the data. So this is actually pretty nice. Right? From an accessibility perspective, this is really, really nice. You can actually do a data matrix. You only want to download subsets of the data. You don't have to download the whole shebang at once. That's really nice. You can do a bulk download. That's also really nice. Or you can do HTTP access, which is great. Now, a couple of things that I didn't screenshot, but just to tell you, unlike the NREL disclaimer on their website, the NIH database websites all carry pages that explicitly state that unless it's otherwise marked, the information is public. So even though this data set isn't explicitly marked that way from an IP perspective, the overarching structure of the NCBI's disclaimers in terms of use mean that this data is, by definition, legally available for reuse in unanticipated ways. There is a privacy aspect because of the genomic sequencing aspects of this, so that in order to get access to the controlled access directories or some of the archives inside the directories, you will have to demonstrate that you've gotten a username and a password from the database of genotypes and phenotypes. But it's not an overtly sort of injurious process to get those compared to other privacy-based systems. So this is actually fairly accessible data, both from an IP perspective and from a privacy perspective, especially given it's human subject data. So you've got 3 clear options to download, right? You don't have a clear license, but you have a pretty clear idea from the overall NCBI website. And because you can download the raw data or subsets, it's pretty highly adaptable. But the complaint has been it's hard to leverage because it assumes that what you want to do is download it and then process it locally, when in many cases the data is so big you'd like to just manipulate it in a different place. You might not even want to download it. You might want to access it through a programmatic client, which is how most data scientists do their work. They do their work in an R client or a Python client. So if you wanted to ask a question like, are there patients that have both tumor and normal samples amid a group of files, you cannot easily do that through the interface that's available, right? That interface is focused on accessibility, right, and leverage in many ways, but only in the sense of getting you the data, not in the sense of the usage that you make out of it. So what we did at SAGE was take the entire Cancer Genome Atlas, curate it, right, do some of that work to make it adaptable and leverageable, run it against our ontology to standardize phenotypes, right, and crawl the whole damn thing and reprocess it so that you could use it in a standardized way in a standardized client. With the theory being, we're a nonprofit, so it's really nice to be able to just give this away. And if we're going to demonstrate the value of that complicated architecture I showed you earlier, if we have to make our own data for that, it's going to take us too long, and we don't have the money for it. But what we can do is take a private data set and make it, or a government data set, and increase its value through curation and good semantics and integration into the technology that users actually use. And this is the sort of thing that you get, right? Basically, we just build layers for every file that we find. Right? We don't change the underlying data, but we build layer upon layer upon layer of information about that file. And then you should be able to, whenever you want to do it in R or in Python. And a lot of this data is latent inside the TCGA data, right? The pivot points that let you get at, right, linking aliquots of material to a specific data file, right, that's in there. That's just a merge that someone has to go through the effort of doing and checking, right? Mapping things to a standardized phenotype, right, is something that is not a complicated thing to do, but a person has to do it, write the script, and a person has to check it. So with the private intervention, right, we make the ease of mastery perhaps a little bit better. Right? Making something available in an R client makes it easier to master for people who know how to use R clients, right, which is a small universe. So I give it a small bit there, but it makes the data much more leverageable because once you're operating inside R, you can do all sorts of more powerful operations on the data than you can do if you're just operating in a browser. And we get incremental benefits on adaptability and accessibility simply by having another copy in another place. It's got a little higher of an accessibility and adaptability score. But the main place where you get a benefit there is the private investment was in leverage, right, and the curation and the annotation that makes that data useful. So the reason for these two is to say that, in a long-winded way, that this concept of open and machine readable, right, it makes it possible for the accessibility and adaptability to be there to the point where either we can nag the government to make the data more leverageable by investing in curation and annotation in systems, Or private entities, whether it's companies or nonprofits, can build jobs based on increasing the leverageability of that data through curation and annotation and what have you. Right? That's a place where markets can emerge, right? But only if the data are already accessible and adaptable legally and technically. Right? It's okay if annotation is missing as long as the data is already machine readable. Then we can add annotation quickly. And it's okay if the data doesn't have the extensive metadata, right, as long as we can copy it and add that metadata to it someplace else. But if you don't have the data accessible and adaptable legally and technically, all the rest of the stuff carries such a high transaction cost, it'll never happen in a commons or sort of open standards-based network. And so that's what this order means to me, is an attempt to set those ground conditions. We can start doing for data what we've done for PCs, what we've done for phones, what we've done for documents, which is to network them. And the network is where we're going to start to see that generativity. And so the thing to close on is when we say open, right, are we talking about open as a philosophy, as a political idea, or are we talking about open as in a methodology? Because these create very different execution paths. Open source is different than free software. And that's why, you're getting all these assumptions when you talk about open data. And you never know when you're talking to somebody which are the ones that they're most sold for. Right? Are they sold into it because of economics? Are they sold into it because of their ideology? Do they think it's going to create innovation? Do they think it creates social justice? Right? Value and values are very different things. And all of these things get wrapped up into the ball of wax that we call open stuff. And what I was trying to do here was to untangle some of those things and stay away from some of those phrases, actually, because they can cloud the argument about why we're doing this. Right? But if you're talking about this in software, the classic formulation is, are we doing this to make free speech? Because then you have the right to edit the software that governs you. Right? You can govern it. Or are we talking about free stuff? Right? Things that do not cost anything. And they create, again, very different outcomes. Now, and I'm stealing this shamelessly from Carol Goebel in the UK, and she has argued that access to research information is free like a puppy, not like speech or beer, right? So when someone gives you a puppy, right, you might not have paid for the puppy, but you're going to pay, right? Because, and this is my dog, by the way, as a puppy. He was free. Right? He was a rescue. He was put into a high-kill shelter, and we got him out. Now, and this is the annualized yearly cost of pet ownership. And this is why I think open data is free as in a puppy as opposed to speech or beer. Food, medical, litter, toys, treats, licensing, vaccines, carriers, crates. This does not count doggy daycare, right, for your oversensitive dog, which we have. The other thing about a puppy is your puppy gets old and dies. And in many cases, data does too. And so when we start to think about what does open and machine readable mean, part of it is understanding that data has a life cycle. Some data we're going to want to keep forever, right? Some data we're going to want to throw away. And knowing how and when and why is going to be as important as it being open, as it being machine readable, as important as its generativity is. When some data has outlived its use, we want to know. And it's worth it, right? This is our dog now, right? We've had him for 4 years. He's brought enormous joy and happiness into our life, and now into our son's life, right? It's okay that this is free as in a puppy, right? It will bring social value, especially if we make it generative, but we have to have a sort of a fairly clear-eyed understanding of the cost of doing this over time, right? Just putting stuff up into an index doesn't qualify. It needs to be not only an investment in the short term, but an ongoing investment and an ongoing evaluation process to know, right, when that data needs to move off to cold storage. And I'll stop there and turn it over to Chris.